The third part of our excellence in the conclusion section is this discussion on sampling variability. So the whole idea about sampling variability is what happens when we take another sample. And if we take another sample, we'll get different data because we're measuring different people. And then also the idea that even within one single sample, like if I take a sample of our Year 12 stats class and look at everyone's heights, I'm going to get different data within that one sample because we are not all identical heights. So in our sampling variability for our achieved and merit, we've already talked about these two key ideas: if I take another sample and if I took a bigger sample. We need to now go into more detail around this. We've got to look at what happens to our confidence interval specifically when we take another sample, and what happens to that confidence interval if we take a bigger sample. The third thing that we want to look at is, does our confidence interval contain our true population median? Because remember, we are taking a sample to try and estimate the population median, but we do only have a sample and not a census. So how good is our estimate? So here's another sample, and what you can see there is there's all these different blue lines in the middle. So these are all different confidence intervals. So the first one at the top would be the first sample of people I take and drawing a confidence interval of that. Then the second sample is the next blue line, and you can see there each of these confidence intervals here, there's a whole pile of these different ones, and they just refer to confidence intervals from different samples that I've taken. So if I take another sample, here is a variety of confidence intervals that I would get. What do we see? Well, we notice that our confidence intervals are all about the same width. So when I look at how wide those blue bands are, they're about the same. Some of them are slightly bigger or slightly smaller, but overall, most of them are fairly close to being the same width. We also notice that the confidence intervals have shifted. So some are slightly more to the left, some are slightly more to the right, some are more centered, but overall, if I think about this in terms of an x-axis across the bottom, overall they're in a similar position. Okay, so we want to think about when we have another sample, when we take another sample, we're not going to get exactly the same confidence interval. But the confidence interval we do get is going to be about the same width because we've got the same sample size. Our confidence interval may shift a little bit to the left or a little bit to the right, but it's going to be staying in the same region. It's about the same location. So that's one key idea. What happens to our confidence interval if I take another sample? Now let's go on to what happens to a confidence interval if I take a bigger sample. So I've got an image here, and I've got on the left hand, on the picture there, my sample size. I've got a sample size of 10, a sample size of 100, and a sample size of 1,000. And then down the bottom we've got our population. So this here is the actual population. There's the true population median. And we don't usually know this, okay? We usually don't know the population median. This is just taking an actual population data set, a census data set, and taking samples from it to observe what happens. So what does happen? Well, these blue lines that we see, those are the different medians. So every time I take another sample, it's drawing a blue line, and you can see there's all the different blue lines that have been drawn for the different size samples. The red lines are actually the box and whisker around the outside. So you can see that every time I take a sample of size 1,000, I'm getting a median that's somewhere around about here, the lower quartile somewhere around about here, and the upper quartile somewhere around about there. If I take a sample size of 100, there's the range of values the median's taking. Here's the range of values my lower quartile's taking and my upper quartile's taking. If I look at the sample size of 10, now we've got a much wider spread here, and the blue lines are very much more there, as are the red lines. So we can see that with a sample size of 10, the median changes a lot. Okay, so the median sometimes is as low as about 155 centimetres. Sometimes that median is as high as 167 centimetres. So we can see there's quite a big range of values that when we take another sample of only 10 people, we can get quite a wide range. Whereas when we get to a sample of 100, the medians aren't varying by as much anymore. They're only going from about 159 up to maybe 163 or 64. So there's a much smaller spread there of where the medians lie. Same with the sample size of 1,000. We can see with a sample size of 1,000, that's much, much more accurate. In all three of those situations, they're all centered around that true population median. So they're all going to give us pretty good estimates. They're about the right position and location, but it's just how accurate those predictions are is going to change depending on the sample size. So let's look at a slightly different graph here, and this is looking now at, so for different sample sizes, what size is the confidence interval. And I can see if I've got 5 users, then this is a confidence interval here, and it's got a confidence interval width that's really wide. With a sample size of 10, the confidence interval there is wide. It's not quite as wide as this one up here, which we can't even see the other half of. And as our sample size gets bigger, so as we go 15, 20, 30, 40, 45, let's look at what's happening to the width of these confidence intervals. And you can see these blue lines are getting narrower in width. So as our sample size increases, the confidence intervals are getting narrower. Okay, and that's that same idea based on what the median is doing. So we're getting more accurate as we take more bigger samples. So let's now look at it from a different perspective. Let's look at it from the point of view of the confidence interval formula. Let's understand how this works. If I change my sample size n, so in my formula I've got the median plus or minus 1.5 times the interquartile range divided by the square root of n. So we want to know what happens as that n value changes, what's going to happen to the width. And if we increase the sample size, so if that increased sample size n gets bigger, our confidence interval gets narrower, and if we decrease it, it's going to get wider. Now let's have a look at why this happens. So let's have a look at these two fractions here, 1 over 2 and 1 over 4. So 1 over 2 is the same as 0.5 as a decimal, so it's a half. 1 over 4 is the same as 0.25 as a decimal. So which one of these numbers is bigger? 0.5 is bigger than 0.25, or a half is bigger than a quarter. So if the denominator, which is the number on the bottom, so that's comparing that number 2 compared to the number 4, if that denominator gets bigger, so I've gone from 2 to 4, it's getting bigger, what happens to the overall value? We're going from half to 0.25. So as the number on the denominator gets bigger, the value of the whole fraction is getting smaller. So that means when we look at the picture there, that's why these confidence intervals are getting narrower, because the sample size is increasing. Okay, so as the sample size gets smaller, the width of this is getting smaller. So that's the key idea there. So let's put that together in a summary. When we take a bigger sample, we've got more information. If I've got more information, I'm more accurate, I'm more precise. It's a good thing. I like having more information. And that means that as the spread of the data, as our sample gets bigger, the spread gets smaller, because we've got a lot more data that is close to the centre, which is our median. So that means our confidence interval, the width of it, is going to get smaller. Now I'm being very specific talking about the width of the confidence interval, because it is the width that's changing. It's not that the confidence interval itself is the values are getting bigger or values are getting smaller. It's still centered in the same location. It's just how accurate that confidence interval, that's what's changing, is that we're getting more accurate. So what does this do to our conclusion? Well, it may change, and that depends on what our conclusion was before. So if the conclusion before was that there was not enough evidence to make the call, then with a bigger sample size, I might now have enough evidence to find that small but significant difference between the medians. Okay, so if the conclusion was I didn't have enough evidence to say that there was a difference, now with more evidence, I might have enough evidence now to be able to say there is a difference. However, if our conclusion was that we already had enough evidence to make the call, then having more data isn't going to change that conclusion. It's going to narrow the confidence interval, so it's going to make us more confident in our prediction, but it's not going to change that conclusion that we already had, because we already had enough information. We already had enough evidence. So that's two of those items. Now the third item is looking at the population median itself, and when we take a sample, how confident are we that we have actually got the population median captured in our confidence interval. So this is looking at a very specific example here. This is talking about a 95% confidence interval. And when they're talking about the 19 out of 20, if you take 20 times 5, you get 100, and 19 times 5, you get 95. So that's how we connect the 95% with 19 out of 20. It's a fraction and a percentage, they're the same thing. So what it's saying that is, if I took 20 samples and I got a confidence interval for each of those 20 samples, one of those confidence intervals, and this one in red here, one of those confidence intervals would not contain the true value, the true population median. So 19 of them will, one of them won't. Now we're not doing specifically a 95% confidence interval, but we're doing, our confidence intervals are around about 95% confident. So that means that when we take a sample, we don't know which of those confidence intervals we have. So when I look at that picture, I'm taking one sample, I could have got any of those confidence intervals. I don't know which one I've got, okay? And I don't know if the one we've got has the population median in it or not. But because most of those confidence intervals that we see there, because most of them have got the population median in it, we're pretty confident that our confidence interval will contain the population median. Okay, so when I look at those pictures, I don't know which, I could have any of those, I could have this confidence interval here, I might have this one there, when I take a sample, I could get any of those confidence intervals. I don't know which one I have, but it's pretty likely that I've got one that does contain that true population median. And so that is our conclusion.